Welcome to C.M.P lab. In this video, we are going to see the rules of logarithm. Remember in our last video we said that logarithm of a number, say n, is the power in which its base must be raised to obtain n. So now we want to see in this video the rules of logarithm, the rules or laws of logarithm. And the first we are going to consider is log to its own base. Log logarithm to its own base. All right, logarithm to its own base. Okay, this rule says that whenever a log, okay, of a number, a log has same base, that it is equal to 1. All right, this is what I mean. Okay, that log b to base b is equal 1. Any log to its own base is equal to 1. Okay, example, we have log 10 to base 10, this is equal to 1. Log 2 to base 2, this is equal to 1. Log 3 to base 3, this is equal to 1. And we can as well prove this, that this is true. Okay, because if we have log 10, okay, we have log 10 here, we have log 10 to base 10. How is it equal to 1? Okay, remember that we said the log of a number, say n. Okay, the log of a number is the power which its base will be raised to obtain the number. Okay, so that this is what I mean. Writing this log in its indices form, or in index form rather, writing this log in index form, this is 10 raised to the power of 1. Okay, equal to 10 raised to the power of x. Okay, we raise the base to an unknown power. Okay, and we said now, or we can see now, that the base on the both sides of the equation are equal. So if we cancel the bases off, the base here cancel the base here, so that we have that x is equal to 1. Okay, so this holds. Okay, this will happen for every log that has the same number with its base. Okay, all the logs in this form, okay, is always equal to 1, and this is the way of proving that. All right, next one is the power law. The power law says that whenever you have a log that is raised to a power, you use the power to multiply by the log. This is what I mean. If we have log m raised to the power of k to base b, okay, that solving this is k log m base b. Okay, so example, applying this. All right, example, we have log 16 raised to the power of 2 base 2. That's solving this. Okay, we take the power, we use the power, we multiply by the log, so that we have 2 log 16 base 2. All right, and if we write 16 in its index form, we have that this is log 2 raised to the power of 4 base 2. Okay, we still apply the rule again by taking the power to multiply with the log, so that we have that 4, okay, 4 times 2, all right, times this 2, okay, log 2 base 2. Okay, so that 4 times 2 is 8. Okay, we have log 2 base 2, and log to its own base is 1, so we have 8 times 1. Okay, and 8 times 1 is equal to 8. Next rule is the addition rule, and this rule states that whenever you have two logs added. Okay, you have two logs added, provided the base are equal, the base are the same. Okay, you take the log to a common base and multiply the logs. Okay, this is what I mean. If we have a log, say log m base b plus log n base b, okay, provided they have the same base. Okay, what you do is you take this to a common log. Okay, take this to a common log b and multiply m times n. Okay, all right, take it to a common base and multiply m times n. Okay, so that this is equal to log m n, okay, base b. All right, okay, let's apply this rule to let's apply this rule. Let's apply the rule. Example, we have log 4 base 10 plus log 25 is 10. Okay, that this is equal to, we take this to a common log. All right, we take it to a common base, sorry, have base 10, we include this, we say 4 times 25. Okay, have 4 times 25. Okay, and 4 times 25 is equal to 100. All right, so that we have log 100, okay, base 10. Okay, log 100 base 10, 4 times 25 is equal to 100 base 10. Okay, so that if we solve this log, right, if we solve this log, okay, we know that if we write 10 in we write 100 in its index form, this is log 10 raised to the power of 2, okay, base 10. Okay, so that we apply the power law here, we use the power to multiply by the log, we have 2 log 10 base 10. Okay, so that log to its own base 10 to base 10 is equal to 1, so that we have 2 times 1, and 2 times 1 is equal to, okay, 2. Right, if you don't want to follow this method, okay, don't want to follow this method, proceeding from here, all right, proceeding from this point, you from log 100 base 10, you can say log 100 base 10. Okay, you write this in its index form, from what we did in our last video. All right, so that we have this. Okay, and if you have this, you write this in its index form. This is 10 raised to the power of 2, because 10 times 10 will give you 100, so the base cancel off, and you see that our x is equal to 2. Okay, the next one we are going to consider is the subtraction law or rule. Okay, and this law says that whenever you have two logs, provided the bases are the same, whenever you have two logs, okay, being subtracted, okay, provided the bases are the same, okay, you take it to a common base, you take the logs to a common base and divide the logs. Okay, this is what I mean. If we have a log, say have log m base b minus log n base b, okay, that this is log the rule says you take them to a common base. Okay, you can either say b and include it in the bracket, okay, however way you want to go about it, all over n. All right, that is what the rule is talking about. Okay, let's apply this rule solving an example. Okay, we have log 28 base 4 minus log 14 base 4. Okay, right. Apply the rule from here. This says log 28 base 4 minus log 14 base 4. Applying the rule from here, the rule says that when the two logs are subtracted, provided the bases are equal, we take the logs to the common base and divide the logs. Okay, all right. So we have that solving this is log okay, bracket open, 28 all over 14, okay, bracket close, to base 4. All right, so that 14 cancel itself 1. Okay, and going to 28 two times. Okay, so that we have that we have, and 2 divided by 1 is 2, so that we have log 2, all right, base 4. Okay, we have log 2 base 4. Okay, and now see this, how can we solve log 2 base 4? Since this log, okay, the number, the log, okay, the number up here, okay, is already in the simplest form. Okay, so we can write it in its index form. It's already in the simplest form. Okay, simplest index form is what I mean. All right, simple exponential form. So we cannot solve it using the methods we use in the other ones. Okay, so the only way of solving this, we will move as saying, okay, following the definition that the log of a number, say n, is the power which is base must be raised to obtain n. Okay, which we know that our 2 is the n. Okay, and our 4 is the base. Okay, so we raise our 4 to a base, say x. All right, and we say equal to 2. Okay, this is the index form of this logarithm. Remember in our last video we said that all logarithm has an index form or exponential form. Okay, this is the exponential form of this logarithm. So if we write this for in its index form, we have already, you know, that 2 is raised to the power of 1. Okay, okay, every number written 1 2 3 4 without a power indicated on them. Okay, without a power indicated on them, you should just know that such a number is naturally or normally raised to base 1, I mean raised to power 1. Okay, so we have 2 raised to the power of 2. Okay, bracket x. Okay, we write 2 4 in its index form, we wrote 4 in its index form. Okay, so this is the x here, we put it in the bracket. So we have 2 raised to the power of 1. Okay, so the bases on the both sides of the equation are equal. All right, so they cancel off. Okay, and we have this. All right, and 2 times x, 2 times x. Okay, 2 times x is equal to 2x. Okay, and making x the subject of formula, okay, making x the subject of the equation. Okay, we cancel 2 by both sides, we divide 2 by both sides. Okay, so that 2 cancel itself, 1 cancel here. Okay, and we have that x is equal to 1 all over 2. All right, next rule we are going to consider is the power of base. Okay, the power of base says that whenever you have a log which is base is raised to a power, what you do is you take the inverse of the power and multiply by the log. This is what I mean. If we have a log, okay, say log m, okay, base b raised to the power of k. Okay, that solving this, okay, is 1 all over k. We take the inverse of k, which is 1 all over k, or rather, okay, we can say okay, we take the inverse of k, 1 all over k, and multiply by the log. Okay, multiply by the log. Okay, so this is what the rule is talking about. All right, so let's solve example applying this rule. Okay, let's solve an example applying this rule, so that we have log, log 16 2 base 2 raised to the power of 3. Okay, what the law simply says is that you take the inverse of this, of the power, so that this is 1. Take the inverse of the power, use it and multiply by the log. So this is 1 all over 3 times log 16, okay, times log 16 base 2, okay, times log 16 base 2. Okay, so that writing we write 16 in its in index form. We write 16 in its index form. We have log. This is we have log. Let's take this off so that we have log we have 1/3 times log 16. Okay, no, we write 16 in its index form. Okay, this is 2 raised to the power 4 base 2. All right, yes, so that we write 16 in its index form, which is 2 raised to the power 4. All right, so that we apply the power law here, which says that whenever a log is raised to a power, you use the power to multiply by the log. So you know that we have 4 times the already power that was taken, that was brought here, times that was multiplied by the log, okay, times 1 all over 3, okay, times log 2 base 2. Okay, so that 4 times 3 is equal, 4 times 1, sorry, is equal to 4 all over 3, and times log to its own base is 1. All right, log 2 to base 2 is 1. So that we have 4 times 1, 1 all over 4 times 1 is equal to 4, is equal to 4. Okay, it's equal to 4 all over 3. All right, so this is equal to 4 all over 3. This is equal to 4 all over 3. The next law we are going to consider is the law that says that the log of 1 to any base is equal to 0. This is what I mean, that log 1, okay, to any base is equal to 0. Okay, whether it is log 1 to base 5 or log 1 to base 6, any log 1 to any base is equal to 0. Okay, whether it is log 1 to base 5, whether it's log 1 to base 6, whether it's log 1 to base 7, whether it's log 1 to base 8, is equal to 0. Okay, all right, so let's see this example. Okay, log 1 to base 10. Log 1 to base 10, this is equal to 0. We can prove this. Okay, we can prove this, that any log okay, to base any log of 1 to base to any base, okay, is 0. Any log of 1 to any base is equal to 0. We can prove this, all right, by saying, let's prove this. Okay, let's prove this. And if you write this logarithm in its index form, log 1 base 10, if you write log 1 base 10, log 1 base 10 is what we are proving, that is equal to 0. If you write log 1 base 10 in its index form, you know that this is 10 raised the base to a power, say x. Remember our definition, okay, that this is equal to 1. All right, this is the index form of this logarithm. Okay, but remember that 1, okay, that any number raised to 0 is equal to 1. That's, I mean, that if any number raised to 0 is equal to 1, whether it's 9 raised to power 0 is equal to 1, whether it's 8 raised to power 0 is equal to 1. Okay, whatever number raised to power 0 is equal to 1. Okay, so therefore 1, it is a base raised to power 0. 1 emancipated from a base raised to power 0, and it cannot be any other base than base 10, because on the left side of the equation, okay, you can see that we have base 10, so it can never be any other base than base 10. Okay, all right, so that this is 1 x is equal to 10 raised to the power of 0. Okay, 10 raised to the power of 0. All right, since any number raised to the power of 0 will give you 1. Okay, so that is where the 1 emancipated from. Okay, that 1 is equal to 10 raised to the power of 0. so that the bases on the both side of the equation are equal. Okay, so that the bases on the both side of the equation are equal, so that they cancel off. Okay, then cancel, then we have that x is equal to 0. So you can now see that log 1 to any base is equal to 0. The next law we are going to consider is the reciprocal law. The reciprocal law says that the reciprocal of any log, okay, the reciprocal of any log is 1 all over that log. Okay, this is what I mean. All right, this is what I mean. If we have a log say m base b, that the reciprocal of this log is 1 all over log m base b. Okay, this is the reciprocal of this log. Okay, the next rule we are going to consider is the change of base. If we have a logarithm, say log m base b, okay, how can we apply change of base for this log? Okay, how can we apply change of base for this log? Okay, the rule says that what to do is you take the base of the logarithm, you take the individual the base of the logarithm, the initial logarithm will take a log of itself. Okay, all right, to the same base with the number, okay, with the number of the log, and then you divide them. All right, this is what I mean. If we have log m base b, okay, applying the change of base here is log m to base c all over log b to base c. Okay, that is the base took a log of itself, okay, to the same base with the initial log. All right, okay, note that the aforementioned rules can only be applied where b is greater than 1 and m, n and k are real numbers, but m and n must be positive. Okay, all right, thank you for watching C.M.P lab. You can ask your questions on the comment box and like and subscribe.